Hey there, Ryan. Very good question, actually. So you'll find that most of the techniques I'm showing you right now follow that with the Cartesian plane, we always start from the 0 or 2 pi or 4 pi, so the horizontal axes, pi and then 3 pi on this side, and 5 pi, and then we add or we subtract from either end, okay? You can technically, you're right, you can technically also add from the vertical axis, so pi and 2 and then 3 pi and 2, you can also subtract or minus from it as well, and you should get the same answer. The logic is that if I give you in terms of degrees, say if this was 150 degrees, right? 150 degrees, then we know that this leftover is 30, but then we know that this leftover here is 60. True? So from here to here is 60. So at this point, you're right, actually. At this point, with a 60-degree triangle, can you see if I drew this triangle from the vertical axes, you are correct. This is where it's tricky, and this is actually one of the last exercises, extra complementary angles. I think it's 14K that you're asking here. If this is 60 degrees there, then this now is the opposite. And this is the adjacent to the triangle. So that means this here is the signed version. So sine of 60 degrees will now no longer tell you the y values, but in this case it tells you the x values, doesn't it? It tells you the horizontal length. So it tells you how far it is horizontally. So it tells you the x value, and then, I should do that. And it equals now to the x value, but clearly the negative version. And then obviously the adjacent side, which is cos of 60 degrees, now tells you no longer the x values, but it tells you the y values instead. Okay, so yeah, you're right. If I did, if you just try to picture what I'm trying to draw here, I'm going to draw this green triangle now. This is the one we've been doing. So this green triangle is 30 degrees and the other one to it is 60 degrees, right? So these are called complementary angles. If I actually took, so here, this length from here to here, that's your x length. That's how horizontally, how far it is on the axes, right? So when you do, to find this length over here using the 30 angle, you would say it's cos of 30 degrees. And then up here, if you were to use the 60 angle, this is sine of 60 degrees. What you'll find is on your CAS, these are called complementary angles because, yeah, it's true. You will get the same answer. So if I quickly show you now, I'm going to change that to degrees. And we do sine of 60 degrees, okay? That's root 3 on 2. But if I do cos of 30, it's root 3 on 2 as well. So yes, you're right. You can say, why don't we add from 90 degrees and we add 60, or you can say 180 minus 30. True? So 180 minus 30 or 90 plus 60 is essentially what you're asking. You're saying, why can't I do pi minus pi on 6? Or you can say pi on 2, in this case, is not pi on 6 now, it's adding pi on 3, which is adding that. So these two will give you the same result. This is 5 pi on 6, and then you'll see here, if you work it out, that's 3 pi plus 2 pi on 6, which actually works out to be 5 pi on 6 as well. Okay? So yes, you're right. The only thing that you're wrong here is the angle. So when you asked here, how do you know whether to add the pi on 6 to pi on 2 or to subtract pi on 6 from pi? You see, in the question, they told us that cos of pi on 6, it's negative, so they only simply tell us pi on 6 is 30 degrees. So all we know is that it's between pi on 2 to pi, okay, it's 30 degrees, and you're asking me, how do we know that it is negative cos of pi on 6? Okay, let me fix what you're trying to say. You're trying to ask, how do we know that we don't do pi on 6 this way, right? And then that cos of that would mean you're finding the height. One, because it's not part of the exercise, but two, the reason why is because what is x representing? See, x is an angle between, an angle between pi over 2 and less than pi. So essentially I'm saying x is bigger than 90 but less than 180 degrees. Okay, so that means the angle I'm working with, x is something like that, right? They're telling me that cos of that angle, so when I draw it, this angle x, which is larger than 90 degrees but less than 180, is somewhere in this region here. So when I pick a point, say here, I get this angle. If this is x, and they want us to find cos of x, right? What they're asking is they're asking for this horizontal length. They're asking for this length here. So this is what I'm looking for. This is the question mark, right? You can find it by finding this angle here. That's possible by finding this length, or you can find this length, right? But what have they given us? They've given us cos, they're saying it's the same thing. Cos of x is equal to the negative of cos of pi and 6. So what I'm saying here is they're saying that this length is equivalent to finding what the negative cos of pi and 6 is. So negative cos of pi and 6. So cos of pi and 6, what does that look like? Well, cos of pi and 6 is 30 degrees. So I know pi and 6, 30 degrees. This is the length of pi on 6. So when they're asking me cos, they're just telling me this length here is negative cos of pi on 6. Okay, so really I'm now working with a horizontal triangle rather than a vertical triangle like you're talking about. Okay, so a vertical triangle would have been the other way around, would have been this, and they would have had to tell you 60 degrees from the 90 degree point, or pi on 2. Okay, but instead they've already told us that it's pi on 6, and this already tells me it's starting on the origin at 0 and I'm moving up pi on 6 because that's 0 to 30 degrees, right? And they're just saying that the value is equivalent to that. That's why I know that I have to work from the x-axis and I'm moving up from pi to keep the triangle the same. Okay, so if I drew the triangle, so what I'm trying to say to you is if this is the triangle they've given us, they said this is 30 degrees and this is negative cos of pi and 6, right? If they're giving me that, they're saying that whatever cos of pi and 6 is, it's the negative of that. That's what they've given me. When I draw my triangle in this quadrant, we know that this 30 degrees here will give me the same length. If you drew it the other way around, if you drew this, on the other hand, if you drew 30 degrees from the pi and 2 point, you see, have a look, this is the adjacent side of the triangle, true? This is A for the adjacent, this is the opposite. Then can you see cos of 30 degrees is no longer true? Can you see here? Cos, this is your A and this is O. So if you did it from the pi and 2 status, A doesn't make sense, because A is now the y values rather than the x value, which is what we're looking for. This is what we want. Does that make sense? That's why I'm working with this triangle instead, not the vertical triangle. I'm working with this triangle to match this triangle to match the adjacent sides. Okay, so these two adjacent sides are the same. The only difference is one is negative and the other one's positive. Okay, hopefully that makes a lot of sense. But your question is actually delving deeper into exercise 14K from my memory. But that talks about you can add from pi and 2, which is true. But for our particular question, it doesn't make sense because the triangles are different. So you can't add from pi and 2 because you're looking for cos of x, which tells us the y value, yet they're telling you that it's negative cos of pi and 6, which is this length that you're wanting. If they had wrote it a different way, if the question was like this, sine of x is equal to the negative cos of pi and 6, then you are absolutely correct. You would have the concept correctly, and that's more of a year 12 question. where you have to find x where it's the sine of an angle, and that's when you have to work